Hello friends, this is Rashmi Singh and welcome to my channel Unraveling Science. Today's topic is Solution for Motion Part 2, Class 9, Chapter 8. Back exercises. First, an athlete completes one round of a circular track of diameter 200 in 40 seconds. What will be the distance covered and the displacement at the end of 2 minutes 20 seconds? So the diameter of circular track is 200 meters. So the radius of the track will be 200 by 2, that is 100 meters. Time taken by the athlete for one round is 40 seconds. Distance covered by the athlete in one round is perimeter of the circular track, that is 2 pi r. So putting the values we get. Now the speed of the athlete is distance upon time. Speed of the athlete. So in place of distance we put the value of 2 pi r and the 40 seconds time. So we get 4400 upon 7 into 40. Now time duration is 2 minutes 20 seconds, which is 140 seconds. Therefore the distance covered in 140 seconds will be speed into time. Now the speed we get from here and into multiplied by the time we get 2200 meters distance. Now the number of rounds in 40 seconds is 1. So the number of rounds in 140 seconds will be 3.5 rounds. After taking start from position X, the athlete will be at position Y after 3.5 rounds as shown in the figure. Hence, the displacement of the athlete with respect to initial position at X will be XY, which is the diameter of the circular track. And we know the diameter is 200 meters. Second, Joseph jogs from one end A to other end B of a straight 300 meter roads in 2 minutes and 30 seconds and then turn around and jog 100 meter back to point C in another 1 minute. What are Joseph's average speeds and velocity in jogging from A to B and from A to C? So as you can see here in the diagram, the total distance covered from A to B is 300 meter. Total time taken is 1 minute, 2 minutes, 30 seconds, which is 150 seconds. Therefore, the average speed from A to B is total distance upon total time. Now putting the values, we get average speed from A to B is 2 meter per second. Velocity from A to B will be displacement, which is AB upon time. Now displacement is same, 300 meters, and the time is also same. So velocity will be 2 meter per seconds. So the total distance covered from A to C will be AB plus BC, which is 400 meters. Total time taken from A to C will be time taken for AB plus time taken for BC, which is 150 seconds plus 1 minute. That will be 200 seconds. 210 seconds. So the average speed from A to C will be total distance upon total time. Total distance is 400, total time is 210. So the average speed will be 1.904 meter per second. So the displacement from A to C is AB minus BC, which is 200 meters. And the time taken for the displacement from A to C is 200 seconds, 210 seconds. Therefore, velocity from A to C will be displacement upon time. Now putting all the values, we get 200 upon 210, that is 0.952 meter per second. Third, Abdul while driving to school commutes the average speed for his trip to be 20 km per hour. On his return trip along the same route, there is less traffic and average speed is 40 km per hour. What is the average speed for Abdul's trip? So let the distance travelled by Abdul to reach school and to return from home be D. In case 1, while driving to school, let total time taken be t1. So average speed is equals to total distance upon total time. So we know average speed here is 20. So d upon t1. So t1 will be d upon 20. This is our first equation. Now for case 2, while returning from school, let total time taken here be t2. Average speed is equals to total distance upon total time. Putting all the values in the second case, speed is 40, distance is d, time is t2. So t2 will be d upon 40. This will be our second equation. Now average speed for Abdul's trip will be total distance covered in the trip upon total time taken. Now so the total distance covered will be d plus d, that is 2d, and total time taken is t1 plus t2. Now substituting the equations of 1 and 2 in the total time taken. So the total time taken will be d upon 20 plus d upon 40. Now average speed is total distance upon total time. Putting all the values, we get average speed is equals to 80 by 3, which is equals to 26.67 meter per second. Fourth, a motorboat starting from rest on the lake accelerates in the straight line at a constant rate of 3 meter per second square for 8 seconds. How far does the boat travel during this time? So given the initial velocity of motorboat is 0, acceleration here of motorboat is 3 meter per second square, and time is 8 seconds. Now we know that the distance is s is equals to ut plus half at square. Therefore the distance traveled by motorboat will be, putting all the values in the equation, we get s is equals to 96 meters. Fifth, a driver of a car traveling at 52 km per hour applies the brake and accelerates uniformly in the opposite direction. The car stops in 5 seconds. Another driver going at 3 km per hour in another car applies his brake slowly and stops in 10 seconds. On the same graph, plot the speed versus time graph for two cars and which car traveled farther after brakes were applied. So car A means initial speed is 52 km per hour, which is equals to 14.4 meter per second. Time taken by the car to come to rest is 5 seconds. Final speed of the car becomes 0 after 5 seconds application of brake. In case of car B, initial speed of the car is 3 km per hour, which is equals to 0.833 meter per second. Time taken by the car to come to rest is 10 seconds. Final speed of the car becomes 0 after 10-second application of brakes. So the speed time graph of two cars will be as shown here. Distance covered by each car is equal to the area under the speed time graph. So the distance covered by the car A is equals to area of triangle OPR. Now putting the area equation is half base into height. So base here is 14.4 OP and height is OR. So we get the distance covered by the car is 36 meter. Similarly, distance covered by car B area will be equal to triangle of OSQ. Now again half base into height, putting all the values, we get the distance 4.15 meter. Since the area of triangle OPR is greater than area of triangle OSQ, therefore the distance covered by car A is greater than the distance covered by car B. Thus the car traveling with speed 50 km per hour travels farther after applying brakes. Sixth figure shows the distance time graph of three objects A, B and C. Study the graph and answer the following questions. As you can see in the graph, which of the three is traveling the fastest? Answer is object B, because it is clear from the graph that B covered more distance in less time. Therefore, B is the fastest. B, are all the three ever exchange points on the road? All of them never meet at the same point at the same time. Fourth, C, how far has C traveled when B passes A? As you can see in the graph, 7 square boxes is equals to 4 kilometers. Hence, 1 square box will be 4 by 7 kilometers. C is 3 blocks away from the origin. Therefore, initial distance of C from origin will be 16 by 7 kilometers. Distance of C from origin when B passes A is equals to 8 kilometers. Thus, distance travelled by C when B passes A will be 8 minus 16 by 7. Now solving this, we get 40 by 7, which is equals to 5.714 kilometers. D, how far is B travelled by the time it passes C? As shown in the graph, distance travelled by B by the time it passes C is 9 square boxes. So, 9 multiplied by 4 by 7 is 36 by 7, which is equals to 5.143 kilometers. Seventh, a ball is gently dropped from a height of 20 meters if its velocity increases uniformly at the rate of 10 meter per second square. With what velocity will it strike the ground, and after what time will it strike the ground? So the distance covered here is 20 meters. Acceleration is 10 meter per second square. Initial velocity is 0 since the ball was initially at rest. Final velocity of the ball with which it strikes the ground will be V. According to the third equation of motion, V square is equals to U square plus 2AS. Putting all the values here, we get final speed is equals to under root 400, that is 20 meter per second. According to first equation of motion, V is equals to U plus AT. So putting all the values, we can find out the time. So here the time is equals to 2 seconds. Hence the ball strikes the ground after 2 seconds with velocity 20 meter per second. Eighth, speed time graph of a car is shown in the figure. Find out how far the car travels in the first 4 seconds. Shade the area on the graph that represents the distance travelled by the car during this period. So you can see the shaded part. The shaded area is equals to half into 4 into 6, that is base into height, which is equals to 12 meters. So the distance travelled by the car in the first 4 seconds is 12 meters. B, which part of the graph represents uniform motion of the car? As shown in the figure, the part of the graph in red color between time 6 to 10 seconds represents uniform motion of the car. You can see here. 9. State which of the following situations are possible and give an example for each of these. A. An object with a constant acceleration but with zero velocity. It is possible when a ball is thrown up at maximum height, it has zero velocity, although it will have a constant acceleration due to gravity, which is equal to 9.8 meter per second square. B. An object moving in a certain direction with an acceleration in the perpendicular direction. It is also possible. Example is when a car is moving in a circular track, its acceleration is perpendicular to the direction. 10th, an artificial satellite is moving in a circular orbit of the radius 42250 kilometers. Calculate its speed if it takes 24 hours to revolve around the Earth. So the radius of the circular orbit is 42250 kilometers. Time taken to revolve around the around the Earth is 24 hours. As the distance here is the perimeter of the circular orbit, which is 2 pi r. So the speed of the circular moving object will be 2 pi r upon t, distance upon time. Putting all the values and converting kilometer per hour into meter per second. So we are adding 1000 by 60 also. So we get the answer 3073.74 meter per second. Thanks for watching. Please do like, share and subscribe.